Okay, let's get right into it. We're going to talk about one of the most critical and honestly most overlooked aspects of AI safety, its own self-awareness. And no, this isn't some sci-fi fantasy about conscious robots. We're talking about something very practical, very measurable, an AI's ability to know what it doesn't know.
This right here, this single idea is the whole game. I mean, think about it. When we're relying on AI for really important stuff, its ability to say, hey, I'm not sure about this one, isn't just a nice little feature. It is the absolute bedrock of safety and trust.
So here's our game plan. We're going to walk through why just having a ton of knowledge is actually a problem, how we can actually measure an AI's self-awareness, what our tests uncovered, and most importantly, why this matters for every single one of us.
Look, today's AI models are, well, they're incredible. They're like encyclopedias on steroids. They can recall obscure facts, write complex code, you name it. But here's the catch. All that knowledge, without any sense of its own limits, becomes a massive, hidden liability.
It really boils down to the difference between being smart and being wise, right? Knowledge is just having the answer, but self-awareness, what we call metacognition, is knowing how much you can actually trust that answer. And that distinction, that little gap, is absolutely everything when it comes to building systems we can actually rely on. So this brings us to the big question for us as researchers and engineers. Can we take this kind of philosophical idea of self-awareness and turn it into something we can actually define and measure? Can we make it an engineering metric?
And the answer is a resounding yes. We're not starting from scratch here. Cognitive science has been working on this for decades. Researchers like Nelson and Narens gave us this amazing framework way back in 1990. It's all about an agent's ability to look at its own thinking, predict when it's about to mess up, and adjust accordingly.
Now, theory is great, but we wanted to get our hands dirty. So we didn't just talk about it, we built a test for it. We call it MetaCog-Bench, and it's the first benchmark really designed from the ground up to stress test these specific metacognitive skills in an AI. And this is the beauty of it. We broke down this big, fuzzy idea of metacognition into 4 concrete skills we can actually measure. Is it well calibrated? Can it see a mistake coming? Can it spot bad logic? And crucially, does it have the wisdom to just say, I don't know? These are the abilities we should be testing in every single model. All right, so we built the test. Now for the fun part. Let's look at the results and see what happened when we ran one of today's top models, Google's Gemini 3 Flash, through this cognitive gauntlet.
Well, what we found wasn't just a little interesting. It was alarming. It revealed this deep, systemic blind spot that seems to be baked right into the way these systems are designed today.
Take a look at that number. That was the model's confidence level. On pretty much every single question we asked it, it didn't matter if it was easy, hard, or straight-up nonsense, the AI was almost always unshakably certain, even when it was dead wrong. This isn't a small calibration error. This is a fundamental failure to understand its own uncertainty.
Let me give you a perfect example of this in action. It's a classic riddle. You've probably heard it. It's a fantastic test of our quick, intuitive thinking versus our slower, more deliberate reasoning.
The gut reaction is 10 cents, right? And that's exactly what the model says, with total confidence. Now here's the kicker. Back in 2005, a study showed over half of MIT students made the same mistake. So the AI is falling into the same cognitive traps we do. But the huge difference is it has none of our self-doubt.
So how do we put a number on this problem? That's where a metric called the Breyer score comes in. The simplest way to think about it is as a penalty score. You get penalized for being wrong, but you get penalized even more for being confidently wrong. A perfect score is 0. The sky-high Breyer score we saw tells us the model's confidence is basically meaningless noise.
So, to pull it all together, the model is just systematically profoundly overconfident. It's actually pretty good at catching simple calculation errors. That's a structured task it's been trained for. But it really struggles to spot flawed logic in a piece of text, the kind of subtle error that tricks humans all the time. And its biggest blind spot, by a mile, is when a question is based on a lie. Ask it, when did Napoleon conquer China? And it will confidently invent a story instead of just saying, wait a minute, that never happened.
Okay, this is all fascinating from a research standpoint, but let's be crystal clear. This is not just an academic exercise. This deep-seated overconfidence has massive, and I mean massive, implications for real-world safety. And this right here perfectly captures the mental shift we all need to make. For years, we've been chasing raw accuracy, just trying to push that percentage higher and higher. But we've been chasing the wrong thing. True safety doesn't come from accuracy, it comes from calibrated reliability. I mean, just imagine for a second, an AI in a hospital that's 100% sure about a wrong diagnosis, or a financial AI confidently recommending a trade that's about to crater. In these high-stakes fields, a single, confidently wrong answer isn't just an error, it's a potential disaster. Knowing when you can trust the machine is everything.
So the point of all this isn't just to point fingers and say the models are flawed. The point is to use these findings as a blueprint to build something better, something safer, and something we can actually genuinely trust.
You should think of a benchmark like MetaCog-Bench less like a final exam and more like a doctor's diagnostic tool. It's not about giving the AI an F. It's about creating a map that shows us exactly where the cognitive architecture is breaking down, so we can go in and fix it and build systems that truly know their own limits.
And that, really, is the fundamental question this research forces all of us to confront. As we design the next generation of AI, are we just building something that knows more stuff? Or are we building something that's genuinely more trustworthy? Because in the end, the future of AI won't depend on how much our machines know, but on how well they, and we, understand the boundaries of that knowledge.